On our ClueCon stage, we have with us Peter Kelly from SourceVox. He has been developing VoIP and carrier platforms with OpenSIR, OpenSIPS, and FreeSWITCH since 2009. He runs SourceVox, an open source telecommunications consultancy in the UK. He's going to be talking to us today about the learning curve of VoIP, from being a non-VoIP developer to being a VoIP developer. The title of his talk is Lessons Learned from Working with VoIP Every Day for the Last 10 Years. Let's give it up a big round of applause to Peter Kelly.
Okay, good morning, thank you. So as you can see from the title of the presentation, I've been working with OpenSIPS and Voice over IP for 11 years. And I was originally a web developer, and I came in to work with a new company, and they were a phone company, and I had no experience whatsoever with Voice over IP. And over the past 10, 11 years, I've attended lots of conferences. I've attended the FOSDEM conferences, numerous ClueCons, OpenSIPS conferences, AstriCons, etc. And it kind of struck me a couple of years ago that the content of these sort of technical conferences seems to be kind of very slowly shifting away from being very, very technical. Sort of 10 years ago, everything was very technical. And it was particularly in FOSDEM in Belgium in 2018. And I sat and watched a number of VoIP presentations. And there were the presentations, but everything was kind of abstracted. So you would have an OpenSIPS blob in the corner, which was like a least cost routing blob, and you'd have a blob over here, which was an edge proxy. And I kind of thought it would be interesting to just try and to say, okay, right, so there's quite a big journey you need to take to get to be able to create one of those blobs. And that's kind of the journey we took. It didn't quite take 10 years, but we've learned a lot over the 10 years. So I just thought it'd be quite nice to just outline what we've learned coming from web development to VoIP development, and the kind of the difficulties you have to sometimes face to be able to get from there to be able to create these cool things in OpenSIPS in particular. So when I started in 2001, I used to work for an ISP and then an e-commerce company. And it was very traditional LAMP stack. I think it was PHP 3. There was no session handling or anything like that. We were using Solaris, rather than Linux. Fairly old-fashioned in comparison to these days, but we had a big learning curve. But it was web development, right? It was making web requests to web servers, making database requests to database servers. Very traditional, very normal web development. And then I got a new job in 2008, 2009. As I said before, it was with a phone company. And I had no idea about VoIP. I don't think I even knew what voice over IP was at that point. I did the traditional thing that everybody does. We got a copy of Asterisk. They were using Asterisk 1.4 for voicemail at that point, I think. And I got 2 phones ringing, and everything was great. Right? It's dead easy. You just fire up Asterisk, hook up some phones, and then make one call the other. It's a relatively simple thing to do. And then they threw me in at the deep end and gave me a project which was to develop a calling card platform. Excuse me. So I went away and researched and founded a project called YATE. So I developed a calling card platform in YATE, which was, I think it stands for Yet Another Telephony Engine, which is very problematic. We had lots of problems with things crashing and things not scaling at all. And then I went away and did some more research and found FreeSWITCH. And I think it was less than one day. It was a very long day. But we managed to rewrite the entire calling card platform in FreeSWITCH, which I guess is kind of a testimony to sort of how easy the dial plan is to work with, even for a newbie. And we had the thing basically rewritten and working in one day in, I think, FreeSWITCH 1.2, I think it was then. Possibly even an earlier version. And then we started doing some interesting things. We thought we threw OpenSIPS into the mix, and we had a back-to-back user agent, which was, I think, quite a new module for OpenSIPS then. And we're trying to do some interesting things whereby we would we'd take the call into the calling card, and we'd capture DTMF, and then we'd try to send the media through different devices, achieving all this with re-invites. And that was kind of the point where we realized that there was this thing called SIP. You know, we'd managed to build an entire calling card platform with applications without really realizing what was going on in the background. And all these applications, they're really easy to use. You can kind of come into them in FreeSWITCH. You can go into the dial plan. You can say answer a call. You can hang the call up. You can play media. It's really, really cool and really simple to do these things. But you're not actually dealing with SIP. And kind of when we started working more and more with OpenSIPs and doing things like re-invites and these kind of things, we kind of realized, and this was when the kind of learning really began, that we were having to learn about SIP and what goes on and how this thing works. So, the first lesson we had to learn was that OpenSIPs is very different to FreeSWITCH in that it handles SIP requests as opposed to just handling this kind of generic call. Lets you handle SIP requests. So you basically in OpenSIPs get presented with the buy message, the invite message, the request, the buy request, the cancel request, etc. And then it's up to you, literally in the script, as the script writer, as a developer, to say, oh, I've received an invite. What am I going to do with that invite now? There's no real concept of just saying in OpenSIPs, answer the call. You have to choose what you want to do with the invite. And that was a big lesson for us. And with that came the concept of learning about a SIP transaction. Previously, we'd kind of considered everything to be just a call. You know, a call comes in, it's set up, and then it gets torn down, and you've had a call. But in the world of a SIP transaction, the actual transaction is just the invite coming in to the final response code that you get for that invite, whether that be a 200 OK or a rejection message. So we kind of had to learn the difference between a transaction and a dialogue. You know, the dialogue represents the whole call, whereas the transaction just represents the request. And just to illustrate it, a quick example. You know, this is a transaction, what it looks like. You get the invite, 200 OK, an ACK, and then the SIP dialogue is the representation of the entire call all the way from the initial invite all the way to the buy at the end. And by default, OpenSIPs is stateless. It will allow you to take an invite and route the call, and literally OpenSIPs will then will know nothing about the call. And it's then up to you as a script writer, when the buy arrives into OpenSIPs, to then do the right thing with the buy. So it's great because it's stateless, but it's also complicated because as a script writer you need to deal with it. So yeah, let's say OpenSIPs is unaware of the call until the next request. Yeah, and here's a quick example of how that can typically be handled. I mean, you've probably seen record route headers before, but say as an invite goes through OpenSIPs, it will typically inject a record route header with its own IP address that says any future requests have to go through myself in order to be routed. And you know, here's an example of the UAC or the UAS on the other side sending the buy, and it's put the IP address of OpenSIPs into the SIP as you would expect. And it works really well. And it means that OpenSIPs can handle really, really high volumes of calls because there's no state. It doesn't have to know anything about the call. It just purely uses the SIP routing headers in order to route the subsequent requests. So that was a lesson we had to learn. But then, inevitably, the next thing we needed to do was to be able to actually manage calls a bit better in OpenSIPs. So that's when we found out about the dialog module. And this module basically makes OpenSIPs more stateful. It allows you to take an invite when it comes into OpenSIPs and say, OK, track this call as a dialog. So OpenSIPs then becomes aware of the call. And it has a downside. You're then introducing state into OpenSIPs, but you're then opening up sort of a whole world of possibilities as to things you can then do with the call in OpenSIPs. So things such as call functions that would validate the dialogue. You can check for malicious injection of headers when calls are being routed through your platform, and just check that people are not trying to do malicious things as they send requests through your SIP proxies. You can also then call a fixed route dialog function, which will say, okay, we don't believe that this is a valid route set coming into our proxy, but we can actually fix it. OpenSIPs can fix it up because it's now stateful. It's now aware of what the original record route set was. It can put the original record route set back into the call for future requests. So that's really useful thing to be able to do. It immediately enables CDR-based accounting. If you use OpenSIPs in its stateless form, then the only way you can do accounting is you account each individual invite and each individual buy, and then you'll have to kind of reconcile them after the fact yourself. If you enable the dialog module, then you can also use CDR-based accounting, which basically means you can say to OpenSIPs, here's your invite, give me a CDR at the end of the call, please. And OpenSIPs will statefully track the call. When the call ends, it will produce a CDR. And it sounds simple, it sounds pretty obvious thing to do, but OpenSIPs is a bit of a toolbox, and you can build all these things on top of it yourself. It also allows call profiles, so you can assign counters to various profiles as calls go through the platform. So you can count how many calls a customer is making. You can count how many calls you're sending to individual carriers, all these kind of things. It opens up that kind of power. And it also lets you inject call control. So you could basically end a call prematurely, or you could initiate a re-invite for a call that's in progress. And also hide the topology. So if you wanted to almost class your OpenSIPs proxy as an SBC, you could use the dialog module to make it stateful, and then you could use the topology hiding module to kind of hide all the internal record route headers for your platform, and also hide the contact IP addresses. So if you didn't want to expose the internals of your network to people sending calls in. Okay, right. The third big lesson we learnt is that IP addresses are important. It's not like web development, where you just send a call to a DNS name, and then there's some load balancer in the middle that will take the request and send it to a web server. If the web server goes away, another web server will come in and take over. We discovered quite quickly that IP addresses are very important. You can use DNS for your initial resolution when you're sending a call, but once that's happened, the actual SIP packet, the SIP request, will contain only IP addresses. And this is really important to high availability. And it was alluded to a lot yesterday in some of the talks about deploying VoIP in the cloud, is that you have to have this ultimate always available IP address. If you've got a call that's lasting 2 hours, the entire proxy chain that call is going to go through and the IP addresses that they listen on have to remain available for the entirety of that 2 hours. It's almost like a 2-hour-long session. And this is important when we come to try and make OpenSIPs and any VoIP platform highly available. So the next question, how do we make OpenSIPs highly available? And this was the fourth lesson. I think this is a fairly classic situation that many people may have seen before. So the classic way to make OpenSIPs highly available is to have 2 of them. You need some level of control in the network to be able to do this. So you have a shared virtual IP address between 2 machines. And one of them will advertise itself as the active machine to the router, which means all SIP requests to that IP address will go to the active machine. There's numerous ways to do this. We've used UCARP, VRRP, Keep Alive D in the past. So that's the classic way of doing it. And then you can use a database to store all your stateful information. because if OpenSIPS Server 2 needs to take over, then it needs to know all the information about the state of all the ongoing calls. And again, the traditional way to do this is to flush it to the database, a relational database. And in later versions of OpenSIPS, you can actually use a clustering module. So the two copies of OpenSIPS, or more, two or more copies of OpenSIPS, will share information between each other about all the ongoing active dialogues. And what happens is, when the inactive server becomes active because there's been a failure of the master, it will read all the dialogue data in from the database, or if you've used the clustering module, it will already have that information inbuilt. So you could seamlessly have a server go down, the VIP will move over to the secondary box within usually less than a second. It will have information about state for all the calls. So essentially, you've more or less achieved high availability with OpenSIPS. And again, you can apply this to other modules in OpenSIPS. You know, dialogue is the classic one because it contains the state for the calls. But you can do it for presence information, for registrar information, and any other number of modules that you happen to be using with OpenSIPS. Yeah, so those were the four big lessons that we had to learn. It handles SIPS requests, not SIP calls. You can use a dialogue module to add your call-based state. We know about IP addresses being important. We know how to make a high availability OpenSIPS pair, and we know how to share information between OpenSIPS instances. And you kind of have to learn all this before you can then start writing presentations that say, here's a blob here, which is the least cost routing server, because all this learning and all this effort goes into being able to create a usable application in OpenSIPS. So just, I think I've only got 5 minutes left. Just a few lessons we've learned running OpenSIPS in production. One of the biggest ones, which is a really, really useful one to have in mind whenever you're writing a new application in OpenSIPS, is that I/O matters a lot. And this can basically be distilled down to the fact that when you start OpenSIPS, it will start up a number of child processes which are there to handle each SIP request. And a child process will take a SIP request and it will let go of it and it will free itself up once that SIP request has been handled. So if you're doing interesting things when you're processing your call, if you're querying a relational database, if you're making an external REST request, if you're doing things that take time, then it can stall the processing of the SIP within the child processes. In this example, we've only got 7 child processes to handle SIP. So you can imagine a high volume platform that's receiving sort of several thousand invites per second. You need to handle those invites quick, otherwise you're going to run out of child processes to handle your SIP. So I/O is a very important thing to bear in mind. It's kind of the number one thing we bear in mind whenever we're writing any applications in OpenSIPS. Because if you have blocking, then you'll have lots of retransmissions and you'll have all kinds of problems, which are not fun to try and sort out in real time. Classic cases are querying a database. If you're going to do this, make sure that you know it's going to be very, very fast. You'll be returning in less than 100 milliseconds, at the most. Writing to a database again, you may think it's easy. I'm going to write some information to a relational database, but you can get deadlocks with volume and at scale, these kind of things. DNS lookups are ones that sometimes catch people out. If you're relying on an external DNS resolution service, you have to make sure that's going to return lookups in a timely fashion. And again, making external requests. If you're going to use a REST service to make an LR endit, for example, you need to know that HTTP service is going to return extremely quickly. Okay, number 5, we've come across, as we've been doing this over the years, what we kind of loosely describe as 3 design patterns for the data that we have in OpenSIPS. We have what we call transitive data, which is dialogue, presence, state information that's kind of important during a call, but then once the call's finished, we don't really care about it. So what we come up with is we tend to store that in a memory-based table. I think it's called a heap table type in MySQL. Or you can share that between OpenSIPS with the clustering module. And the idea behind this is if the OpenSIPs fails, we don't really care about retrieving that data too much. There's persistent data, which is the data that the actual application requires to run. So it might be dial plan or routing information. And we tend to try and store that on a local relational database adjacent to the OpenSIPs instance itself, just so it can read it in very fast and you're not dealing with reading data in across networks, especially if you're deploying multiple POPs around the world, as it were. And then you've got your important transactional data, which is your CDRs. And we tend to handle those with events, or if we can, we write them to a relational database that's replicated or backed up as it's important data. And we tend to find that every application we write, we can fit the data into these three patterns. Excuse me. And it's worked very well for us. A few tips for building applications. Authenticate your invites and registers. One we come across loads with customers and other people we work with is that you can make a call without being registered. You know, people expect to have to be registered to make a call, which is not the case. Drop every packet that you don't want as soon as you see it. And there's a number of modules in OpenSIPs to do this. You know, you've got the permissions module, the Pike module, 2 examples. Beware of cancel requests, because they may look like a regular request, but in actual fact, you have to handle them in a slightly different way. And the most useful one really is to log everything. If you've got a complicated application in OpenSIPs that's doing least cost routing, that's like looking at carrier cost information, that's making decisions on call failures, it's inevitable that at some point you're going to get support requests that say, why did we fail over to this carrier? You know, why did we not send a call here when we could have sent, it was cheaper for this call at this time? At that point, you need logs, basically, to go through the decision process that your OpenSIPs application made while it was routing that particular call. Okay. Yeah, so we've covered a lot. I think this was originally a 1-hour talk I did last year at the OpenSIPs conference. And we've covered quite a lot already. If anyone wants information from these slides, I'll put them up somewhere so you can download them and try and digest all the references to various modules and things. But where we've come to at the moment, we've really only covered the kind of basics of using OpenSIPs, of using the various modules, making it stateful, handling high availability, best practices in script writing. And we've come all this way, and we've not actually written a single application yet. So, you know, the next thing is you can actually start to write your application, start to use the accounting modules, event modules, mathematical modules. If you look in the list of modules that comes with OpenSIPs now, you can do some pretty amazing things. You know, as you're routing a SIP request through a SIP proxy. So I'd encourage everyone to go and have a look at the list of modules available, and kind of you can do some really cool stuff. So there we go. It's a very big topic. We've learned a lot over the last 11 years. I've tried to distill it into a 25-minute talk, so hopefully it's not been too much of an information overload. But yeah, I mean, we've done some really cool stuff with OpenSIPs, and once those building blocks are in place that I've tried to outline here, then yeah, you can really, the world is kind of your oyster with what you can do with a SIP invite. Okay. Any questions?
Big round of applause for Peter Kelly. All right, do we have any questions for him? We have one right here, a black shirt. If you could repeat the question so that everyone in the audience can hear.
Yeah, out of the 3 high availability options, CARP, VRRP, and Keep Live D, what drives us to choose one over the other? We initially used VRRP, and the networking, the guys were concerned about, I think, a patent issue from Cisco with VRRP, I think, and we moved to UCARP. And we tend to use UCARP now, unless we don't have to. Sometimes, I mean, I was discussing with Liviu, if you've got a unicast situation, it's better to use Keep Alive D. because I believe UCART relies on multicast and you can't have that in all environments. We've got some people we've worked with who also use BGP route advertising, so they run like Exa BGP locally on each machine and it will advertise BGP routes. So yeah, it really is a lot of the time what your individual circumstances will allow you to do. I mean, OpenSIPS supports Anycast as well, so then that's a possibility if you've got, total control of the network.
Other questions?
So what was the question?
What's your usage for event routes?
What's our usage for event routes? Mainly, we will put important information from the application, important events that happen in the application, we'll raise them into an event route, and we will actually just send them straight into something like RabbitMQ, like a messaging bus, and that can just take it away and do the right thing with it. But we use it for that, and we use it for accounting CDRs. And that was especially useful. We used to have, we've got POPs in the US and Europe, and one of the interesting challenges is writing from a relational database across a wide area network, which is not really the best idea. And we used to do all kinds of things to solve that problem, and now we use the event route, raise an event, log the event, and send it to RabbitMQ, and RabbitMQ can just move it between a cluster to wherever you happen to be handling your CDRs this day. Yeah.
Any other questions? Going once, going twice. All right, big round of applause for Peter Kelly.
Thank you.